So we would like to proceed with our next session, the panel discussion on careers beyond academia. The panel today will feature Dr. John Mather, the winner of the Nobel Prize in Physics in 2006, and he will be joining us virtually today. We also have with us Dr. Zhou Lihan, CEO and co-founder of Meraxis, which is a Singaporean biotech startup, and Dr. Shi Xu, founder and executive chairman of Nanofilm Technologies International, a leading provider of nanotechnology solutions in Asia, sorry. So moderating the panel today, we have Dr. Lim Jui, CEO of SGInnovate, a Singapore government agency that supports entrepreneurship centered on the development of deep tech. So please warmly welcome the panel this morning and our moderator as well. And I will now hand the session over to Dr. Lim.
Okay, oh, I'm here. All right, thanks. Okay, good morning, fellow young scientists. First of all, I just want to say how privileged I feel to be here. I ran a panel last year as well. I think this is one of the best things to happen for young scientists all over the world. So really, really happy to be here. My name is Jui. I'm the CEO of SGInnovate. SGInnovate is a venture capital company at heart, but we don't believe that money solves everything. So we're also involved in community building and talent development. Those of you who were in Singapore last week might have seen some of the news around a new platform that we're building that connects talent demand with talent supply, so jobs, as well as training demand and training supply. So we're going to try to aggregate training providers across Singapore so that anyone who wants to learn, to upskill, reskill, has the ability to do so. Yeah. So today's discussion on non-academic career pathways for scientists is totally up our alley. And there's something we believe in because employment as we have known it has been changed irrevocably, right? I mean, I think I read in today's newspapers, Microsoft is about to lay off 10,000 people. The notion that there is such a thing as an iron rice bowl, to borrow from a Chinese idiom, is no longer true. And that creates some very interesting, the consequences of that are quite interesting, right? Because it means that things that we had previously considered to be risky, such as entrepreneurship or taking non-traditional paths, suddenly become less risky. But don't take it from me. We have assembled a great cast today. Just because science was your first career step, you don't necessarily have to take a traditional route. So joining us today, hi John, by the way, I didn't get a chance to say hello to you earlier. But joining us today, we have Dr. John Mather, who's you can see him on the screen, who's joining us from California, I believe. John?
No, Maryland, actually.
Sorry, Maryland?
Yes.
Oh dear, so it's quite late for you.
It's fine.
So John is Senior Astrophysicist and Goddard Fellow with the Observational Cosmology Laboratory at NASA's Goddard Space Flight Center. Dr. Mather is an extremely accomplished scientist, and he leads the research on the James Webb Space Telescope, which was launched on Christmas Day in 2021. A few months ago, I was in Berlin at the Falling Walls Conference, and I had the pleasure of listening to a presentation on the James Webb Telescope by one of John's colleagues. And I'll just say this, it made my hair stand, right? It detects light that was emitted millions of years ago in an effort to understand how the universe was the origins of the universe. Consequently, he is the recipient of the Nobel Prize in Physics for his work around the Big Bang Theory. Immediately on my right is Dr. Shi Xu, who is the founder of Nanofilm Technologies. This was spun out of the Nanyang Technological University in 1999. Today, Nanofilm supplies materials that exist on the majority of your handphones, unbeknownst to you. Right? So it's almost a very ubiquitous technology in handphones. And nanofilm is one of Singapore's deep tech unicorns. And finally, on my far right, we have the CEO of Meraxus, Dr. Zhou Lihan. Meraxus is one of the fastest growing biotech companies in Singapore. It uses microRNA to develop early detection kits for cancer. Today, his 350-strong team works across labs and facilities in Singapore, the US, China, and Japan. So I have a ton of questions for my panelists, but this session is not about me, it's about you guys. So I expect that there will be a lot of questions. Please ask questions. We also have a virtual audience. So what I'm going to do is I'm going to take 3 questions from you guys, and then I'm going to take 3 online. For our online audience, just so that we can cover as many topics as possible, if someone is asking a question that's identical or similar to yours, perhaps just vote for it instead of asking the question separately. And so if that's okay with you guys, I'll get started. And I thought I'd start with you, Lihan. Yeah? Because you're probably closest to our audience. You're the youngest. Lihan, tell us, why is it important for young PhDs to consider careers beyond academia? What's in it for them?
Well, first of all, thank you for having me. Not that young anymore, hitting 40 this year, and been in this this journey of starting a company since about 10 years ago. And the first thing I would say is there seems to be this notion that the moment you get into a non-academic environment, you're no longer advancing science, which is absolutely wrong, right? We did not spin off the company thinking, hey, this is how much we're going to make, and this is the amount of product we're going to sell. No, never. We spun out of A-Star in 2014, and before that, in 2010, we so-called crossed from AUS to A-Star. People call that cross to the dark side because A-Star had more money, right? Which is quite
For our
interesting.
global audience, A-Star stands for the Agency for Science, Technology and Research. It's the equivalent of NSF and NIH, for instance.
Yeah. Thank you, Trey. So our step from the university in the first 10 years of doing basic research of understanding what RNA is, what microRNA is, what PCR technology was about way before COVID, and moving to A-Star, which is really focused a lot more on translation of the technology and to spin off the company, is the natural step in taking an innovation and discovery to impact. So I would say even today, we don't quite ask the question what, who we are as entrepreneurs or technopreneurs. We ask, have we delivered impact? Have we taken the science that was developed to reach the impact, which is why we are in science in the first place, right? So I don't truly think there is a huge differentiation in terms of doing good science in an academic environment versus doing that in a translational startup environment. The goal is still the same. But I have to say that the day-to-day focus can be quite different. And we can be quite tough in terms of what project works, what project doesn't work. Sometimes, yes, a hypothesis failed, and we restart that in the university. But in a company, if that, especially in the bad economic environment like now, certain pipelines gets canned, certain pipelines gets chopped, because we just have to focus in delivering something that will reach impact faster. And money and revenue or profit will come if we deliver impact. But if you look at the dollar sign, I would say, that's not the best way of reaching that impact in developing science.
But nevertheless, I think when you join a startup, unless you're one of the lucky few who joins an incredibly well-funded startup, I mean, did that, very often you have funding for a limited runway And that's very different from working in a big company or in academia where you can, there's visibility. It's a longer horizon. So how did that affect your decision? Or you were, you were so convinced that this was going to change the world, it was not even material?
So I've never attended any business school courses before I spun off, and that's probably the core reason why we just went ahead, right? And A-Star, I have to thank A-Star that did a wonderful job, because for the 4 years that we were with A-Star, we essentially got a yearly contract. You hit your milestones, you get a contract renewed. You hit your milestones, you get a contract renewed. Which kind of positioned the mindset, instead of, I've got 5 years to finish my PhD or 7 years to finish a PhD, or in a big company, we got 10 years to do a project. Essentially is prove that what you claim, prove your hypothesis is true, and prove that it makes impact, right? However small that may be. So with clear milestone, what we are thinking of at that point is not, okay, what Morexus will be in 3 years, 5 years, or 7 years, but in that journey of bringing a RNA technology to become a cancer early detection blood test, right? There are 4 milestones. Do we have the right biomarker? Can we make it into a kit? Can we manufacture that? And can we go through clinical trial? Essentially the 4 milestones. And we were focusing on hitting that milestone. And each of these were a year, 2 years away. And of course, we have to raise money along the way. But if the impact is clear, the market is clear, by hitting milestones, it's actually not difficult, especially at the later stage, to raise money. But I have to say, 10 years ago, and Trey knows this a lot better than I do, when we spun off, I had to do 600 pitches to get the first dose of money. So it wasn't easy. And on this island at that point, there were less than 10 VCs that were even entertain a meeting with someone that talks about RNA and PCR, right? But along the way in the last 10 years, the ecosystem, and Trey mentioned in his introduction, it's really not about the money. You got the right technology, the right purpose. If the ecosystem is growing, if you can find the good people, money will come and impact will be made.
Thanks, Lihan. I'm going to move on to John. John, it's such an honor once again to have you at our discussion today. John, could you just tell us a little bit about the path you took from university and how you ended up at NASA?
Yeah, sure. I went to graduate school at University of California in Berkeley, thinking that I wanted to be a theoretical physicist like Richard Feynman, who's such a hero to so many young scientists. And I was there and I'm thinking, well, this is very, very difficult. I asked my advisors, should I do this? And they said, no, there's no funding for theoretical physicists. All those jobs are taken. So I started asking faculty, what should I work on? And I found some people who were going to try to measure the cosmic microwave background radiation. So I said, that sounds interesting. I'd like to work with you. And so we started. And so we made one successful measurement from the mountaintop in California, and then we built a balloon payload to measure the spectrum of the cosmic microwave background radiation, which is the remnant of the early universe. And so I wrote a thesis about that, but the first flight of that equipment failed. So I had to write a thesis about a non-functioning payload. Okay, well, I was very fortunate that my thesis committee and thesis advisor said that's good enough. So I got a job at the NASA laboratory in New York City. And I thought, well, this work I've been doing is too difficult, so I'm going to try switching to another subject. So I thought, I'm going to become a radio astronomer, which is different. Anyway, I had been there about 6 months when NASA called for proposals for new scientific missions. And I thought, okay, well, I only know one thing, but I'll say we should try this. So I said to my boss, well, my thesis project failed, but we should try it in outer space. So we wrote a proposal and we sent it in, and that became the Cosmic Background Explorer satellite that did measure the Big Bang and send us off to Stockholm. So that's how it got in. And it was a big surprise. It was not a plan. It was just saying yes to opportunity. And
but John, at the point,
yeah.
Sorry, just a quick one. At the point when you left Berkeley for New York, though, what was the thinking process? Was it just because there was no funding no further funding at Berkeley, so you had no choice,
No,
or
no,
you went there clearly that you didn't want to stay in academia, you didn't want to stay to be a professor.
no, that's much simpler. I got a job offer.
Okay.
I got a phone call from NASA. Would you like to work with me? So I said yes. So anyway, then we did build that project. I moved down to the big science laboratory in Maryland, where I am now. And then when that was done, then I said, what do I do now? And I got a phone call, another phone call from unexpected. Would you like to work on this new telescope, which is what I've been doing ever since. So my career has not been about detailed planning or particular persistence. It's been about saying that yes to opportunity.
Thank you, John. John, I think the audience would love to hear a little bit about the James Webb Telescope. If you could just indulge us.
Yeah, sure. Yeah, it is a 6.5 meter diameter telescope. It is in outer space now, 1.5 million kilometers away from us. And it is cooled down to a low temperature of about 50 Kelvin so that it can observe infrared light from the many sources in the distant universe, ranging from the most distant objects we can see, the first galaxies and stars that grew from the Big Bang material, to stars being born inside dust clouds, to even planets around other stars. So it's took 27 years to build it after I got that phone call. And now it's up there and working perfectly with beautiful pictures every week.
Incredible, incredible. But as you look back over your very long and distinguished career, is there anything you would have done differently, knowing what you know today? Or this has just been
I was very cautious and shy, and I did not ask people for help along the way. And I think it would have been very interesting and productive to say, well, I have this idea, can you help me with it? But I didn't do that. I guess I can't argue with success, but I think it would have been more fun to talk to more people, to just say, well, what are you doing? I've got an idea. And I recommend that to young people. So I was lucky, but I think it's even better to be active.
Thank you. And what was some of, I mean, you've had so many incredible achievements, but what would you rank as the 2 or 3 greatest milestones? And how do you think they've shaped your worldview as a scientist?
Well, I think my milestones that I can take personal credit for are relating to creating the Cosmic Background Explorer, the COBE satellite mission, because that was my idea. And I had a particular technical concept that we did actually build. So I really am proud of that. And we did not know what we would find. So we were very fortunate that the universe yielded up some secrets that were worth a prize. So sometimes you build something and nothing happens. But we were fortunate that there was something to find.
Do you think your colleagues who stayed in academia, I mean, if you had stayed in academia, would you have been able to do the same thing?
I don't think so.
Yeah, and that's principally because of NASA.
NASA has resources of engineering teams and support systems that enable these large projects to be built. And if you're at a university, you do not have access to that directly, although you can propose to get such help. So if I had been at a university, I could have written the same proposal and we would have found a way. But personally, I think I really like very difficult, large projects, and it's a pleasure to work with these great teams, and that's harder to do in universities.
Thank you, John. I'm going to move on now to Professor Zhou Lihan. Okay, Lihan talked about how difficult it was in 2010, but you were even crazier. You left in 1999. You were already an established professor at Nanyang Technological University. So, Prof, take us through what happened.
Well, thank you very much for having me here. Yes, I would think my path towards the commercialization and entrepreneurship was quite unique, not conventional. For example, as a nutshell for example, I failed to raise any fund before I start up the company.
Did you fail or did you choose not to?
Actually failed, really. Yeah, the interesting thing is I was in the vacuum coating line, and the vacuum coating technology, if you understand that, is a very slow-moving field. Over decades, mostly the changes are engineering. Okay, engineering refinement, machinery refinement, but there is hardly any fundamental shift, breakthrough in coating industry. So I had a long term of research work, collaborating with overseas colleagues, Cambridge and Sydney, and even USA also, some companies, we worked together. And we had some interesting discoveries and breakthroughs. And especially in Singapore, I led a team and filed a few patents and solved quite a few fundamental issues. So we put a particular coating technologies into a commercial path. But then it was a very new thing, and it was not proven, and it was difficult to actually to get recognized, accepted by the market. It's very deep, so we're talking about deep tech. It's really deep. Once you are really deep, you don't have the tunnel to reach the ground. So after a couple of years of many attempts, and we actually had it nowhere. We couldn't get people putting money to start a company. But then the interesting thing is that we did a lot of samples to all the world, the companies, and one company and tested the sample, and I found that this is exactly what they want for the next generation product. That was Hitachi, Japan. So after very intensive evaluation and so on, so they, I don't know why, they just issued a PO, but they didn't know whom to address to. So I said, no, I mean, the university, in the laboratory, I couldn't accept your PO, no way. So we found a local Japanese company too to act as an agent. So they accept the PO. They don't know this PO transfer to where. So eventually the university would think that that's something that we have to think about actual commercial now. It's no longer just talking and flowing around. So we really need to do something. So at the time also, for me, another interesting thing is I never had any commercial experiences. I didn't know anything about running a company. I didn't actually plan to leave university at all. But at the end, this is something you see, you feel so happy that your technology was required, was recognized, and about to be used in real world, right? So that is kind of an impulsion, and it just pushed me and come out to do something. And as I said, that this is entirely a accidental event, entirely unplanned, and we didn't have any capital to start, but yeah, we had a PO though. So we had an advance payment from the customer. So it's a very different path, and from beginning until now, we never in red. It's always we were always making money, and although struggle for a long time, but we went through.
But was it scary? I imagine it must be quite scary. I mean, you're not going to have the same salary anymore.
Yes.
There's uncertainty.
Yes.
You left a tenured position.
Yeah.
This is
I think, it's really depends on individual aspiration. Since I was a kid, I really liked doing things. Roll up the sleeves, make some mechanical stuff. It's typically electronic mechanics is really something I love. And so it's very individual. I would say academic life as a researcher is a wonderful life. It's a wonderful career. And we can make such impact to the society by new discoveries, by new inventions. But then, if you want to see the commercialization process in front of your eyes yourself, and if you want to roll up the sleeves and do something yourself and make products and interact with the world, and to sell your product, offer your product in real applications, then if you are this type of people, you have this kind of impulsion in your heart, then probably there will be another path to go.
So now that you've made this decision, so again, it just shows how important serendipity is in so many ways, and will, the desire for self-determination. Having crossed the Rubicon, what were the biggest hurdles? Now that you jumped into the abyss.
In my case, it's really, I think as an academia, in the past, one just deals with materials, right? Yeah. It's a material world. You bury yourself every day in the lab, and talking to the machines. And I still remember almost 35 years ago, my research supervisor and introduced me to some of his friends. He said, "Oh, this machine is his wife." So that's how we do and how we make breakthroughs, right? So you have to bury yourself in the work to really communicate, talk to the objects you're working with, right? But then, if you decide to go on to the commercial world, to me it's a shock, because now you need to deal with another two dimensions. One is the market, and the other, everyday people. Right? Very, very different experiences, very, very different skill sets you need.
So how did you bridge this gap? Recognizing that you had no business experience, what did you just decided I'll just learn on the job, or did you take 1 or 2 courses in accounting?
Yeah, I think skill sets, sometimes you have to make up, you have to do something to enrich yourself. For example, as anyone doing business, you must learn to read finance. You must learn to some basic logics of accounting. Right? You need to know the corporate structure. You need to understand people deeply. Right? And you need to understand your customers. And you always strive for win-win situations. Right? So it's a very long and struggling process sometimes. But as I always think, as a successful entrepreneur, you need to have certain attributes, certain traits. Like you must have the passion, definitely. You must have the passion. You must have the vision. And not only that, you must have the determination, right? And you must have the skill set to execute. Execution, you can't just play lip service. You need to actually do things, run operations. Right? You need to cost conscious. Right? You need to drive down the cost and deliver good service and products to customers. And you need to be constantly innovative. We can't lose our innovation. Right? Although the environment is very different, for example, in the laboratory, in order to write a scientific paper, you do 100 experiments, one successful, verified success, then you can write a paper. Probably many papers to follow. But in the industry, in order to offer a product, to sell a product, at affordable price to customers, you need to do 100 times and 99 times probably successful. Right? You don't have room for error. And you need to constantly improve your workflow and constantly drive down the cost. And one big shock when I left university was that I no longer work on budget. There is no people giving me money. You have to earn the money yourself, right? You have to live on yourself. So I'm a very old school. I don't like those economy that basically burn other people's money. I think you need to burn your own money.
Lihan, how about you? I mean, you mentioned earlier also when you started, you had no experience on the business end of things. How did you address those gaps?
Every pitch we made, just like Dr. Xu said, every customer we met was a learning experience. So I would say in initial days, I was told, right, the end goal of that pitch is to get money. And after 100, you realize that you have failed 100 times, and you got to change your mindset. Otherwise, you're going to go into depression. So I say, it's okay. Every pitch is to understand what I've not done well, and more importantly, what can we improve in terms of the technology, in terms of the product positioning, in terms of even engaging people. Dr. Chi is absolutely right. When we moved into the world of commercialization, early stage, it's all about understanding why would a pharma company that's based out of the US entertain us? I mean, we're nobody, right? We're a Singapore lab, yeah, we specialize in microRNA, we publish a few good papers, but why would someone based out of the US want to give you that $250,000 for the first PO, right? And it was really, for me, is learn on the job, do it. But I think what I probably did right was be very open to hear what people are telling you, right or wrong, right? And we make a decision in terms of what makes sense to us at that point, right? So, and I think, as PhDs, if you have gone through that training, we didn't go into PhD to learn the subject. We did PhD to learn how to learn. And when we apply that in the real world, that's all it takes, honestly. I mean, you can read a business book, you can read accounting. Those are not difficult for scientists because it's all about logic. It's just that we have to switch the logic from the material, the cells, into human. And I think that's the most difficult but an essential path to cross.
Thank you, Lihan. John, I expect that you don't come under similar profit and loss pressures, but that doesn't mean there aren't any pressures. I mean, what kind of pressures do you face running a program of such, I imagine it must be quite expensive, but also hugely significant?
Yeah, so I'm actually not the manager who has to manage all those stresses about the budget. So I work with the managers to make sure that they understand why we're doing what we're doing and what the scientific value is. And then other people's job was to go convey the budget to the people who have the money to spend at Congress. So NASA is so large that we specialize in these different parts. So my particular part is to sort of explain and show the value of what we're trying to do so that people don't lose sight of the reward at the end of the project while we're thinking about how to get the resources to complete it. So I've always had a very optimistic view, and I think that shows in the world. We built something that was had no competition. There's no other way to get the information we were after. And so that was part of my job, is to explain all of that to the world so that they could see it. So then the details of how many people does it take to do something and how long does it take, that's a very different subject, and I'm not good at that part. So I'm just glad that we do have people who are.
So that I think that's such a important point, because sometimes, and I'm sure the both of you will agree, you're not going to cover all the bases. So it's very important to build good teams. John, did you have a chance to pick your team, or was this kind of provided for by NASA?
Well, the team grows organically. When you have a manager and people want to work on your project, people volunteer. They say, "Can I work on your project? It's so wonderful." And then the managers and the NASA system basically organize the rest. So I didn't actually have to do very much about evaluating whether such a person is a good person to be on the team. Also, we have a very competitive process with proposals and reviews for all of the commercial partners. So we don't say, "I know how to build this, build it like this." We say, "Okay, world, write me a proposal for how you would do this, and then show me that you can." So then we spend a lot of time at NASA making sure that they are actually able to do that. And so that's how we get to do the nearly impossible. We ask the world, "How would you do it?" And somebody says, "Yeah, I can do that." And then we say, "Prove it," and then we do it.
Fun. Juicy, you also mentioned that one of the greatest challenges in the private sector was managing people, right? So tell us how you dealt with it. I mean, what is your philosophy when it comes to hiring and then developing them and maintaining them?
Yeah, thank you. And that from beginning, that was a challenge because my team, only myself, had experiences in vacuum industry. I had a bit of experiences in building machines and the process. All my engineers, they all came from different disciplines. They could be electronic engineer, they could be software engineer, mechanical design engineer, but none of them actually worked for vacuum equipment. So we had to spend many hours, just go through from the very beginning, the vacuum beginning, how to create vacuum, how to maintain vacuum, how to build the vacuum equipment, what are the important components, one by one, right? Just and to link them with their previous work knowledge. I mean, they are all basically fundamentally linked with basic logics. So nothing is isolated, right? So you need to pave the road for them to learn, as just Lihan said, that we need to learn how to learn, right? And to deal with people, I think that is a very important thing. It must come from yourself. You must have a good self-assessment. What you are good at, right? And which area you can lead. And you need a team. For example, like sales. I'm not good in sales at all. I don't think I have the character for sales. Right? And I think marketing is a science, and research is a science, but sales is art. So I don't think I possess that kind of artistic skills for sales. But then you need people to help. Right? You need a team. And you really need a team in HR, finance, right? And you need a team for engineering work and to deal with customers, to really be friend with customers, know their challenge, know their pain points, and how we can solve. So all these need teamwork. And you need to be humble. You need to know that many places you are not as good as your team people, right? We need to work together, brainstorm, and everything on table. Don't talk anything behind after you leave the meeting room. So execution, same direction, right? Same strategy, same mindset. So these are the very, very important. So I think most important for a founder and to start something by yourself single-handedly, we still need to be extremely humble, right? So you need to rely on your team member to work together with you. And you need to learn along the way many other good things from your team members. Right? But to make things really organized, I think some key skills, very, very important. Organizational behavior, for example, right? You need to know how people work in the organization, right? And how people generally behave in the organization. And you need to know what a company is for. The company is there to make profit, right? To make benefit to stakeholders. It's not a generalized family. It doesn't possess a lot of family attributes. It's there for commercial exploration, to make money, to make profits, and to benefit the stakeholders. So we need to keep focus.
These are very important learning points. I think in my experience in venture capital, we also see a lot of people who are young CEOs who get so distracted. I mean, it is true, fundraising is a big part. Without the money, there's nothing you can do. But then they become so fixated, they forget there is a team back home. And that team needs to be healthy. The relationships need to be maintained and nurtured. So I'm going to stop here because just watching the previous session, there were so many questions. I want to just give us, because it's really for you, I'm going to give us adequate time for questions from the audience. So I'm going to take the first 3 from you guys, and then I'm going to see if there are any questions online. I see there are 2 questions. The young man in the green shirt, please introduce yourself and fire away.
Good morning, I'm Patrick Fuchs from University College London. I'm a postdoc there, and I think many of us postdocs here are looking into the future and seeing a bleak academic prospect because there are very few tenure positions. I don't know if at this point I would give up a tenure position to leave academia, but I think industry is a very real possibility for many of us here. Anyways, it's a very sharp funnel. I was just wondering, maybe this is more relevant for the venture capital, but was there ever a moment where I understand you're more able to make impact in industry, but many of us go into science both because we want to make a change, we want to change the world or have an impact, but also because we're curious. So do you have a feeling that moving to industry has impacted the way you can satisfy your curiosity about subjects that you're working on?
Anyone you want to direct this question to, or shall I open it up?
Just open up, yeah.
Okay, who wants to take a crack on that?
Maybe have a go first.
Please.
I think, the actual lasting driving force, the internal driving force is always, as a scientist, always the curiosity, always the desire to make impact, and the desire to see your technology being put in practical use. And even in a company, I think you can do that. But obviously, you need to select the things you do. You must do the area that you are good at, and you have your breakthroughs, and you really created something there. Take example, for example. Recently, a year ago, we started a journey on hydrogen economy. Okay, and particularly, I think this is the last leg of my working career. I want to devote most of my time and energy onto that because I see this is impactful industry. And that comes to our fundamental deep tech research. And for hydrogen fuel cells, you need to solve a series of engineering issues. And it's not a principal problem. Everybody knows how it works. Everybody knows how to make a fuel cell in the lab. But the problem is the cost, efficiency and the cost. So you need to solve a series of engineering issues to make this really commercializable and not based on stipend, those allowances or those projects from the government. You have to make this work commercially.
But there is a trade-off, right? I mean, there is a trade-off. You must contain the curiosity bit because you have to make
the curiosity. You shift the curiosity into like how to make it actually work. More towards from fundamentals gradually. Actually, it's a much wider spectrum. As a scientist, always, for example, the deep tech, we involved in the deep tech, we invented the coatings for metal BPP, bipolar plates. And so far, I think this is definitely the best coating available for metal BPP. So this is the fundamental part, deep tech stuff, all from the laboratory. But then you need to refine it, need to make it successfully on the plates, and need to test it, verify it in the real stack. Right? So this gradually coming towards more engineering issues. But then you need to keep your curiosity. You still need to be curious how to make the whole thing work, right? And along the way, a lot of fundamental issues you still need to solve. So I think there is no immediate conflict. And it depends how you divert your energy and your thinking. And as long as you're doing, for me, my only experience is towards like deep tech commercialization. So as long as we're stick on deep tech as the anchor, and a real as wide tunnel as possible to reach the ground, that's the commercialization, to reach the ground, provide real products. And the whole process will give us such fulfilling mind, yeah.
Thank you.
Thank you.
I believe the young lady in the white shirt is next.
Hello.
So forgive me if I'm getting the order wrong, but why don't you go ahead? Please introduce yourself. And
Very inspiring story. My name is Regina Huang from the University of Hong Kong, and I'm thinking of starting my own business after I graduate. So my question is, how do you build an effective relationship? Especially, how do you find people who share common interests with you?
again, is there someone you want to direct this question to, or it's open to the panel?
Open to the panel. Thank you.
Okay, maybe I'll assign this one to Lihan.
So your question is, how do you build relationship and
Build
find...
an effective relationship. Like, I find it kind of difficult, especially with a lot of people, but it's hard to maintain a long-term relationship with others.
Absolutely. So I think through my early days, the one thing, I can't remember what changed that, was the shift from caring who we are, what we can do, to why are we relevant to the person we're talking to? Because as scientists, we are so proud of our discovery, we're so proud of the things we do, and we go out and tell people, I'm wonderful, this is a great science, this is going to change the world. Forget about all that. The question is, so what if you publish a Nature paper? So what if you publish a Cell paper? How is that relevant to Mr. John on the street, right? So I find to be a lot easier to communicate and build that rapport by thinking, why would John even talk to me? Why am I relevant to him or her? So what if we have done great science, right? We talk about impact. But in our mind, at least when I was in university at A-Star, the impact is a patent, a publication. We go present this at a conference. That's the impact, the immediate impact. But it doesn't translate into the real world. So we have to ask, because give you one example. So we developed these blood-based cancer early detection tests, right, to catch cancer early. Wonderful idea, we go pitch to VCs. Nobody will disagree with the idea. But when we go to the real world, we did a free community screening at one of our Singapore district. We screened 242 elderly, 60 to 70. We found 2 aunties of high risk. And both aunties, when we approached them to take the next step, said, no. I don't want to know. Even if I have cancer, let me die. The other auntie said, I have no money to treat. So thank you for doing this free screening for me, but just let me go. Right? And then you realized it takes a lot more to achieve the impact, because the impact is to find the cancer early. if the two elderly aunties, for whatever reasons, is not willing to take the next step, your 10 years, 20 years of work, and millions and hundreds of millions of dollars into developing that wonderful test is useless, right? So we have to think about what is the ultimate impact, define that, and define who do we need to work with to achieve the impact, and really understanding that person. So take ourselves out of us as a scientist, and now think as an everyday person, why am I relevant? That was a huge awakening for me, and I just had a much easier time communicating with people that way. Yeah.
But Regina, were the relationships you were referring to, you're talking about relationship with your customers or relationships with co-founders? How do you find somebody who will start a company with you? How do you build a team? Is that, which relationships?
The co-founders mainly.
Okay, so, all right, so let's just, did you start the company by yourself or you had a few co-founders?
I was fortunate. We kind of spun off the whole lab. So it was a group of people that we had the relationship and trust over a period of time doing research together. So that was very fortunate, in my case. But subsequently, we did have to bring in, new team members and all that. So again, the same principle, I would say, matters, right? And the first question I ask generally during job interview is, how is Meraxas relevant to you? Not the other way. Because I want to understand, what can I do for you, right? And if this individual's interest aligned with the company's interest, then it's an easy path, right? So again, I apply the same principle to build trust with my customers, to my stakeholders, as well as the team. It's always, like Dr. Shi said, win-win situation. But we have to be very, very honest with each other, right? Like Tree has, alluded to. If we're not honest with each other, we hide our interests or we hide our concerns, that's not going to work. Yeah.
Thank you.
I'm just going to take a derivative of that and ask the same question to John. John, you were looking at making proposals for some seriously big, projects. Surely you didn't do this by yourself. I mean, I know you had a manager to manage, some of the budgetary side of things, but as a team, though, how did you find I imagine you did have a team, first of all.
Yeah. So we do have teams and we do have process for building teams. And let me suggest that there's a book that was written by a NASA manager about how NASA builds teams. That's actually the title of the book. And so it points out that we need to recruit people of all kinds of different talents, and that we should be in the organization, we should be doing the things that we're capable of and that we like to do, because we are not interchangeable. So basically, in a big organization, you have a pretty wide range of choice of who you would like to have to work with you. We say, oh, I know this best person that's been doing this before, and I really want that person. And then, of course, those people are always busy doing something else. So there's a matter of persuasion to say, well, I have this really wonderful thing. Will the organization let that person work with my project? So that's always a very tricky thing.
And it's once again, it's called How NASA Builds Teams. That's the name of the book. That's actually the name of the book. Thanks, John. Okay, I'm gonna move on to the young lady in the gray dress. I think you came third. Please introduce yourself and fire away.
Yeah, my name is Maha, and I'm from the University of Illinois, Urbana-Champaign. I have a question about when do you know that the technology is ready to move to the commercialization stage? Because in lab there's a lot of technology which people develop, and it's really you get a perfect result. But when do you know okay, I'm ready now to move on?
Prof?
Yeah, that is a very, very good question. I think many young people will encounter this problem before they start something. And that's why, all the VCs, they have all people assess technology. They do technology due diligence. But for self, if you want to start something, And you need to have a self-assessment, right? You need to really look at the technology you created, the product you're trying to create from a very neutral position. You need to really look at the how to, at the beginning, you need to really study how to survey the market. So whatever you want to do, you try to address which market. What are the market area and the people you want to target at? Right? And are they real? And how many competitors? How many competing products around? And do you have any uniqueness? I think the most keyword is any product you create, you want to sell, do you have any uniqueness? What is that different from all the other products selling on the market? Is it pioneering new product, or is just try to compete and grab market share from other people? Right? So be truthful to yourself. And a lot of niche products you create or niche technology you make breakthrough, it may end up different exit ways, right? And some may be just a good supplement for another bigger corporation, right? And part of attachment to another bigger setup. But some you really can stand by yourself, and you can develop verticals and really to grow a business yourself. But that's, of course, is rarer. It's more difficult to do that.
But Maha, I think there's always an element of risk, because there's no formula, unfortunately. But these are guideposts. But that's all they are.
Yeah, I agree, because like also some of like the risk which we can think of is like, let's say like a technology which is like in lab is successful, but what if it's like failed when you're like doing a commercialization or trying like to make it like to make a part like more accessible to like, let's say, the end users.
Yeah. John wants to chip in. Go ahead, John.
Yeah. So I think we've already made it pretty clear that the main thing that's important is what do the customers want more than what do I want. So in order to find that out, again, I would just recommend getting help, asking people, would you buy this? And what is the defect that you see in my idea? So making presentations and trying to convince somebody until you really feel that you've got it right is a pretty important thing. If you just say, I know what to do, then you probably don't. If you have passed the test of convincing many people, you have a better chance.
Yeah, I think that's great advice. Be honest with yourself, do an honest self-assessment of yourself, your product, and know when to get help.
Thank you very much.
Reach out, yeah.
Sure, if I may, chip in here. I give you one easy answer to that is someone willing to put down money for that?
That's true.
For us, we didn't raise money until 2 years after we founded the company. But similar to Dr. Shi, within a week of founding the company, I had a $250,000 PO from US. So either a venture capital is willing to put down money to bring your technology to the next step, because in many cases, in order to advance a technology towards commercialization, you can no longer do so in an academic environment for various operational reasons. And secondly is, if a customer is willing to pay actual money to use your technology, right? So that could be a validation of, yes, it's mature enough to go to the next step. Now, it doesn't guarantee that you're going to get a second PO or third PO or fourth PO, or you will actually materialize. But if someone is willing to put money on the table to help you, do it. Yeah.
Thank you. Okay, the young man in the light blue shirt.
Well, thank you very much. My name is Chuck Ng. I'm the co-founder of the World Leading Scientists Institute. We're actually affiliated with both Berkeley and Stanford. John, first question to you is, as a fellow Berkeley alum, congratulations for your success. My question to you is there like a eureka moment, or there are a series of eureka moments for you on the things that you did that helped you to win the Nobel Prize? And what's your advice to doing hard science, because you actually fail initially? So that's the first question for you. And then my question for the panelists is, what's one single advice you have for these young scientists if they want to start their own company? Thank you.
Go ahead, John.
Oh my goodness. Yeah, so the eureka moments for me are when I see that there's an idea that I have that actually solves a problem that other people want solved. So when I saw that I knew how to measure the spectrum of the cosmic background radiation, I knew I had something really important to do. And so I was willing to work on it until we could solve it. So I think people knew right at the beginning of our Kobe satellite that there could be a Nobel Prize in it if everything worked. So we knew at the beginning that it was important. So that was the eureka moment at the beginning, that it was important. And a similar one happened when we started the new telescope, the Webb telescope, because we knew there was no other way to do that mission besides this gigantic thing that we built. So you're guaranteed to win if you can do the project when you have something so unusual. So that was my eureka moment, or a couple of them. So recognizing when you have a really, really unusual idea.
John, how important was that Nobel Prize? Was that a real incentive, or was it just,
No,
a nice to
not
have?
at all.
Yeah.
It's I don't do things to get a prize. I do things that I think are important, and I'm happy when somebody else agrees that they're important.
Thank you. Thanks, John.
Thank you, John.
Panelists, you want to take on Chuck's second question, which is the single piece of advice, right?
Single most important advice now.
Yeah.
That would help, like the young scientists to, to start their company, because obviously you guys have a lot of industry experiences.
To start, I was thinking of perseverance. The reason for that is we're going to encounter a lot of challenges. The decision to start being one of the most difficult decisions to make, right? And we're going to face a lot of naysayers. We're going to face a lot of no's. You're going to get more no than yes. So you just got to persevere. If you believe the work you want to do, you believe it's going to achieve impact, just persevere through.
Now, I think I come from the product point of view. I think for anyone who wants to start something, to make something, need to be very, very truthful, looking at the uniqueness of your product. Really need to examine the uniqueness of the product. And the other, of course, there are so many other factors, parameters so important for success. But you need to center around the product. So what do you want to sell, and how unique it is?
Yep, thank you. I mean, I think there's actually coherence between what John and what you guys said, which at the end of the day is you just have to really work hard and persevere and never give up. But it's been fantastic attending here. So thank you.
Thanks, Chuck. Okay, I'm just going to turn over to the online questions. It turns out there aren't that many. These are the questions. Okay, it's not showing up on the screen. Okay, let me just ask the first one. This is a person who did not identify themselves. The question is, how do you think industry and academia can join forces to deliver greater impact? I'm actually going to start with John first, although it may not be obvious. But John, do you have private sector partners in let's say the James Webb Telescope, or is it entirely a NASA project?
Well, it's a NASA project in the sense that we receive the money from NASA headquarters and then we spend it on companies.
Okay.
So I think 90% or more of the money that we receive is spent on companies to do things. So we recruit them all through the proposal process. They write a proposal, they say they can do the thing we need, and we say, oh, okay. So and that applies to even things that you hear about like a SpaceX and so forth. We buy rockets. We
Okay,
don't tell
so
them how to build the rocket.
so you were using SpaceX rockets to deliver the telescope into space?
Well, we did not this time because our international partnership called for the European partners to produce the rocket for us. So they did.
But in general,
But I'm just
what
giving
is
you-
yeah? But how
The
important
European
is it?
rocket is also a private company. It's it was not a government agency in Europe that built it either. It's a private company. So most of the work that big NASA projects do is on contract to some other organizations.
So they are important partners. The ability to work with
Yeah,
is.
if they didn't exist, we could not do the telescope.
Are there any downsides? I mean, are there times when you wish I didn't have to depend on somebody else?
Well, of course, but on the other hand, they know what things to do, and I don't know them. So as and you're thinking about building a team, you have to have a team that includes all the kinds of expertise that cannot possibly exist in a single organization. No organization is big enough to build a telescope like this because nobody knows everything.
Thanks, John. Professor, want to take a crack at that? How do you think industry and academia can join forces to deliver greater impact?
I think this kind of collaboration or joint force is quite natural. And for corporation, for a company, not many companies will do very deep, low TRL research, right? Technology readiness level. And you need a sizable, very well-run, profitable company to do a deeper and a deeper research. And so many times you, as a company, and overall you have your research and development target and strategy. You need to work with the university. I think that's the best way. You need to leave more challenging, scientifically challenging topics, directions to academia to explore, right? And work together in a more freer, more open environment. And I think that is a better environment compared to in a company to be more open-minded and really discover, invent some very new stuff. But once the TRL levels raise up, right? When it comes to like TRL like 4, 5, 6, then some company will start to take it over or will take on to develop together. I think there is a great concept or the practice in Singapore. That's called Corp Lab, Corporation Lab, right? Corporate Lab in local universities. So we set up a Corp Lab in one of the local universities to work very closely together with the academias and to take advantage of multidisciplinary options and possibilities and to work on real low TRL stuff, right? But not from 1, 2, 3, probably really we need to collaborate with academia and as their research projects. But for 4, 5, 6, maybe that is the area that we need to focus on Corp Lab. Then once you raise up to like 7, 8, 9, probably more and more, it will be more suitable for the corporate to develop products. So I think it's a very natural collaboration and a lot of opportunities there. I think for people really love academia research work, love the university research institute environment, it's not really necessary. You must jump out to join a company. It's a great opportunity there.
Thank you. Okay, I see another question here. I love working, not identified, anonymous. I love working in a lab, but worry about the instability of finding a new PhD or postdoc every 4 years. Any advice? John, you want to take a crack at this? I suppose this is your situation is probably closest to the context here.
Well, mine is pretty clearly different because I don't actually work in the lab. I work with people who work in the lab. So
I see.
in our situation, we have people who are basically in their jobs for 10, 20, 30 years. So it's pretty stable where I am because we have long-term projects. And so it's kind of the opposite of the corporate world close to me. When we hire a company to do something, those companies have to be very agile because when they've completed the job that we've asked them to do, they may or may not need the people that they have. So they have to be always looking for the next contract. So it's pretty interesting and tricky. So,
Lihan?
so the people are
have-
paid more, but they have a higher risk.
Yeah. Thanks, John. I mean, I imagine you must have quite a few PhDs in your labs.
We do.
Or postdocs.
We have about.
Is there a big
40
turnover?
No, actually, we don't have a lot
Okay.
of turnover in the last 8 years. But to be honest, I think stability is overrated. Why should we have stability? Whether it's in academia, whether it's in industry, why should there be stability? I mean, looking at now, on average, a grad student, or through our career, we have 7 to 8 jobs. If you count it back, every 2, 3, 4 years, you change a job. Sometimes because of the situation, sometimes because your interests change, and down the road, maybe your family want to move to a different location. So I think the best way my advice is forget about stability. Focus on why are you in the lab for that 1 year, 2 year, 3 year, or 4 years, however long that is. But if you put stability in that equation, I don't know which job today.
But I think the question is coming from the standpoint of, let's say, the manager or the head of the lab, though. He or she doesn't want to have, I suppose his or her question is, how do you create an environment so that people are not leaving every 4 years? If I'm not wrong.
Right. I think for PhD, generally, we stay there for 4 or 5 years, and then we move on anyway. And for postdoc, at least when we move into a commercial research environment, most of my research team has been with us ever since the founding. Right? So as long as our skill set is still relevant, the company's research direction has not changed, even though we may move from disease to different disease, but the team never really moved. And then we bring in new skill sets, machine learning, I hesitate to say AI, but data science, right? So there can be stability both in academia as well as industry, but provided you actually want that stability.
All right, I'm going to come back to the audience here. I'm so sorry. I know you guys have been waiting for a long time. But I believe the young man in green came first, so please go.
Hi.
Yeah.
My name is Kazuki from Japan. And so this is a little bit off topic, but my question is regarding to the country-based difference of the environment of startups or ventures. So I'm from Japan, and Japan is, for some reason, it's not really good at incubating ventures or startups. So this means there are not many young scientists try to make a startup or ventures in their career. So in this context, as far as I understand, Singapore is much more successful on this point to, incubating young scientists trying to make some startups. So I was wondering what makes Singapore more successful in this point. So could you tell me your thoughts on this?
This question is for you, Trey.
Oh my God. Look, we're reasonably successful, all right? I don't want to oversell it, but certainly with we've created conditions so that today, if there's another Prof. Shi or another Lihan, hopefully it will be smoother, right? So today, some of the work that we do, building communities, very important. People think a community, what is that? Is it a nice to have? How important is that? But I think it's important to build communities so that potential entrepreneurs can meet other entrepreneurs, understand their experience. They can meet people who may be manufacturing their prospective product, and they can learn, can we actually make it? There may be service providers, people who may need, let's say you need a quality management system. You may meet someone in these communities. So we believe community work is very important. I think the presence of venture capital is sort of, once you hit a certain level, it becomes a virtuous cycle. I mean, if you look at ecosystems like Israel, I mean, it's really incredible, right? I mean, success breeds success. And then, of course, there's an element of culture. So again, if we look at Silicon Valley or Israel, there's a very unique culture, right? That the circumstances have conspired to produce. So every country is going to be different. I don't think we can compare. What we've done is to try to address the bits that we can control. I think we're reasonably successful. I think we're seeing more and more young people do this. But, there's still room for improvement. And hang around, join us. If you're not seeing opportunity back in Japan, come talk to us.
Thank you so much.
Thanks. Okay, finally. Young lady in the orange trousers.
Greetings, everyone. My name is Carol Zetungwenya. I'm from the University of Cape Town in South Africa. So my question today is on technological readiness. So when your technology is ready to hit the market, but the market is not ready for your technology, what would you advise one to do? I ask this question because there's often a disconnect between the work that we do in the lab and societal needs and industrial needs. Do you advise someone to stick around in postdoc until there's enough societal and political pressure to accelerate the uptake of your technology?
Prof or Lihan? Go ahead, Lihan.
So allow me to ask this. If the market is not ready for the technology, what makes us think the technology is ready?
Proof of concept?
I'm sorry?
Proof of concept. The technology has been tested to work. It's
Yes.
just the market and probably might require a mental shift from society to take up the technology as yet.
Right. So, well, I'm in a bit of a similar situation years ago, right? Everybody wants to cure cancer. Everybody wants to detect disease early, but nobody seems to want to pay for it, right? Or at least people haven't figured out a way to pay for it. Or the technology may be too expensive, right? We may be able to cure cancer if we spend $5 million on a personalized treatment. So in that situation, I guess the question is, if you're able to find the venture capital to support that early journey to get it through, because a lot of sharing economy, Uber, Grab, burns a lot of money. Until today, it's still burning money to get the market ready, right? So if you're able to convince the venture capital to put on the money to create the market or to educate the market, then that's fine. If not, then perhaps stay in the academic environment or go into a research institution to try to bring down the cost if cost is the issue, or to work with the right stakeholder to educate the market to get it ready.
But I think there's no black and white answer. I mean, if you look at Elon Musk, I mean, who'd have thunk it, right? He wants to put man on Mars. He dreamt of electric vehicles before there was even infrastructure. Certainly the market wasn't ready. So a lot of it is also, just how visionary and how determined you are. So it's a little It's an experiment. You titrate to effect. John, you want to chip in? What's at what point does NASA think, okay, this James Webb thing, this telescope is, is it driven by the fact that you could do certain things technologically, or, were there other factors that were at play with James Webb?
Well, excuse me, the way that we got started was a committee wrote a book that said, please build this telescope. And then they outlined all the scientific reasons that it was so important, that this was clearly the next scientific discovery after Hubble. Mm-hmm. So it had to be big, it has to be cold, it has to be capable of infrared observations. So they wrote out this wonderful book about the scientific discoveries that could happen. So then it was NASA's job to make a plan that would carry out developing all the technologies to the necessary TRL-6 before we could choose and complete a design. And then, of course, that always turns out to be harder than one thinks. It turned out, after we had all that and we designed the thing, then the hardest problem is proving that it works. It's much more expensive to prove that it works than it is to build it. So anyway, we definitely go by a TRL schedule. We have standards of reviews, and we have to satisfy external reviewers that we've done a good job at every step. So there's a process to say, yes, it's mature enough to go on to the next step. They hadn't made any big mistakes, and they're ready. And of course, Congress won't send us the money if we don't do that.
How much money are we talking about, John, with the James Webb Telescope?
Altogether, the U.S. portion is 10 billion, about. And I'm not sure how big the European and Canadian contributions are. They're smaller, but they're still large.
Wow.
So, but over the course of 27 years, it's, well, it sounds like a lot, but compared with the size of the space budget, commercial and military together, which is about $400 billion each year, this is still a tiny fraction of the worldwide expenditures on space. But it's the one that's in the news every day.
Indeed. Thanks, John. Okay, let's take the next question. Okay, it looks like everyone is lining up over there. So, young lady in the white T-shirt, please go ahead.
I'm Felicia from Singapore.
Can you speak up a little bit?
Hello, I'm Felicia from Singapore. So I was just wondering, like, for businesses that actually stem from novel technologies, how do you actually sustain it? Because there may come a point where, like, you may not be able to grow your customer base anymore or expand your product line based on your novel technology. So, and then we know that for novel technologies, the development pathway may be longer, much longer. So in that scenario, how do you sustain your business in the long run?
Well, I suppose you've just heard Lihan and Prof. Yeah, it's important to get that right before you start. Okay, well, I mean, when you hit a brick wall, what did you do, Prof?
I think that first of all, still, like, you need to reassess your technology and your product. And it seems that probably you don't have a TRL9 product, right? So you still need to continue to work on it. But if you already have certain applications, right, you sell to a smaller audience or smaller market, then I think it would be a wonderful base to continuously to improve on it, and to base on what you have and make it better. And of course, you need to think loud about go-to-market strategy, right? And how to expand your market, expand your audience. And if your product are already accepted in certain area, certain audience, then obviously there is a value in it, right? But you need to make a product better is a daily issue. Yeah, it's a continuous improvement.
Yeah, you gotta assess, reassess, Be honest with yourself and keep improving, keep innovating. That's the only way out of it.
Thank you.
Thank you.
Hi,
Yeah.
Pichayut from Thailand. So actually, I'm a co-founder of Thai Cacao Starter Cultures and for the fermentation process.
I'm sorry, could you say that again? A founder of?
Thailand Cacao Cocoa, you know, for
Okay.
chocolate. Yep.
Okay.
Starter culture for the fermentation process, which intend to enhance the quality of the taste and flavor of Thai chocolate. But sometimes when I go to meet the farmer or my customer, they think that I'm coming like a scientist. The difficult thing is coming to them. Do you have any suggestion of this?
I'm sorry. Did you all catch the question, or you want to go ahead and answer?
If I caught you correctly, you're saying that you present yourself as a scientist, where your customer may not appreciate the way you present your technology.
Yes.
Yeah. So I think it's really, you know, to put yourself out of that scientist hat and think like your customer, right? And perhaps in your particular case, have you worked in the field to think like them, to understand where they are coming from, right? The best is to be in your customer's shoe, experience what they are doing, understand their pain point, and understand why your technology is relevant and how would that make their life better.
Yeah. And the quick question is, do you think that the startup is only a word of trainings, word of trainings, and it's going to be sustainable in the future? The word of startup, do you think it's only a trend or it's going to be sustained in the future?
Is it only a trend?
I don't think it's a trend. A startup basically means that we're taking something new into a highly agile environment to develop it to the next step. Right? So in fact, if the world stops doing startup, I think we have a very big problem.
Yes.
Thank you.
Thank you.
Hi, I'm Danica from University College London. And we realize the importance of getting feedback, but in the field of biomedical engineering or biomedical devices, it's quite easy, based on my experience, to end up in this never-ending cycle of trying to fulfill what what people want. So we have easy access to the feedback from our funders. Our funders want this, our doctors want that, or our patients want this. And then it comes to a point where we don't know when we're ready to launch. So I know that there's always a way to improve, and research work never ends. I mean, everyone here knows that. But how do you know for yourself when you're actually ready to launch this product or launch this telescope?
John, you want to take that? I mean, earlier you had said get advice, get help, but sometimes they may be too much of a good thing. So how do you integrate?
Yeah, so I can only give the example that I know, which is at NASA. We have to convince serious engineers and managers that we've done the right thing. And we have books written of standards about how to tell this. So we have to get people that are not working on the project to come and read what we've written and listen to our stories for days on end to say, have they done everything they should do? And we have hundreds and thousands of written documents to say, this is what we said we would do, and we've done it. So there's a very formal process that we go through to make sure that we are ready, because we have to, because failure of a piece of space hardware is often not repairable. So we must do everything right. When it's, if I try to imagine how this applies to a commercial venture or a startup, it's a little different because it's a little less definite what people need to have from you, and it's somewhat subject to persuasion. But it's still good to have people who will be hard on you and tell you when you're making a mistake. One thing a lesson I've drawn from my history is never trust the boss, especially if you are the boss.
Thank you, John. Okay, we have a minute and a half. So, Lihan, you want to quickly take that? Just, how do you know when to launch? How do you distill the feedback that you get or the various inputs?
First of all, everyone's got a feedback, especially physicians. So, PhD is pretty bad, physicians. Okay. The second part is for biomedical devices. The moment we lock in a spec and go into production and clinical trial, you can't change that, right? So it's critical in the early days, there's a certain minimal performance that everybody agree, at least, your key stakeholders agree. So the moment you hit that, lock in the spec, move on to the next step. Then you can think about generation 2 or 3 in the later stage, but you have to lock in. You have to lock down so that you can move to the next step back, right? There's ISO standards on that. But yeah, don't take everybody's advice. There's never ending.
Prof?
Yeah, exactly. I think in our line also, we call it POR, the process of record. That means you need to lock down. You need to lock in the process to generations by generations. So one generation completes, you lock it in, POR, and you need to push to the market. And any further improvement, that's generation 2.
Thank you. Perfect timing. With almost surgical precision, we have hit the time limit. So I want to thank our panelists, John, once again, for joining us from Maryland. Have a great night ahead. Thank you so much for joining us. Lihan, Prof, equally, thank you so much for joining us. And thank you.
Thank you, Dr. Lim, and thank you, panelists, once again, for that illuminating discussion.